In this video, we're going to talk a little bit about tools for measuring forest carbon in greater detail than we have before. This video assumes that you have some familiarity with the general carbon cycle, and then we'll move forward from that. Carbon pools and fluxes can be measured in simple ways or complex ways. You've seen a slide like this before, and this slide is pointing out the difference in complexity between methods. Some tools and methods are very simple. You can adapt forestry methods to measuring carbon in above ground portions of trees and soils very readily. So diameters of trees, general volume of logs can be matched with estimation equations that estimate biomass of trees based on their size, or equations for volume of material like down woody debris that can be matched with density estimates for those same pieces of down woody debris. These techniques are very simple operationally. They require many hands to make light work. They can be hard in terms of taking a lot of measurements over rough terrain, but they're relatively simple in terms of the technology that's needed. Other tools for measuring carbon flux involve gas sensors, large towers, things like eddy covariance towers, which are pictured on the bottom of this slide. Eddy covariance towers tend to integrate wind direction, temperature, moisture sensors, along with infrared gas analyzers for carbon dioxide to integrate the movement of air and estimate net fluxes into and out of systems. Eddy covariance towers require specialized personnel and large infrastructure. These approaches require permanent staff that are constantly monitoring data streams and a constant monitoring of flux rates of gas into and out of a system, in addition to some complex quantitative skills required to process those data and take data of air movement and changes in CO2, temperature, wind speed, water, all of that, and integrate it into a full picture of gas flux from a forest canopy into the atmosphere. Many locations instead take a permanent plot approach, which is an approach that requires repeat measuring of forest plots through time to compare stocks of carbon at different points in time, at which point you can compute the net changes in carbon fluxes. You can't calculate, or you can't estimate very well the gross fluxes of carbon into or out of a system using this approach, but you can calculate the net changes. To some extent, the eddy covariance tower allows you to look at both gross and net changes. Permanent plot approaches require empirical estimates from ground-based measurements. Generally use a permanent plot network, a series of plots that are repeatedly measured with definite bounds. These are fixed area plots. And we can ask questions about what causes variation. You really need long-term data sets in order to use this approach. Short time periods will only result in small changes in carbon, and those will be hard to measure or they will be confounded with plot error. So you need long time periods in order to use a permanent plot approach and to do good error checking so that a single year's measurement doesn't accidentally throw your measurement off. It's also good for people who are new to measuring carbon at all or measuring forests. People who are relative novices in the field of forest ecology can quickly contribute to robust data sets, especially if sample sizes are large. On the EON network at the Evergreen State College, we use a plot design that's a 10-meter radius fixed area plot. We do carbon inventories in these plots every 1 to 3 years. And then in the past, we've used a web-based database for data archiving that used to be housed at evergreenecology.org. That's now been updated, and we now just use a Google Sheet and freely share our data with anybody who's interested. We take a subset of our plots across our network, and we do more intensive measurement of specific carbon fluxes in addition to just inventory. Plot network designs and permanent plot designs, though, vary tremendously. This is an image of the FIA, or Forest Inventory and Analysis plot design, which is a series of many, many plots spread throughout all of the United States. In this design, there are three subplots assigned to a given well, there are, I'm sorry, four macro plots associated with a single plot location. Within that, there are four subplots. Within that, there are a series of transects and even smaller microplots, all of them associated with measuring different components of the forest system. So different size plots for different measurement goals for measuring different components of the forest system. However, this is a permanent plot design, and it's one that's been applied widely across the United States. Other studies around the world will use even yet still different plot designs, not always with nested subplots, sometimes with nested subplots, and sometimes with a single plot. Plot sizes in forestry and carbon inventory will vary from designs that use many, many 1/20th acre plots, or 8-meter radius plots, very small plots, all the way up to 1 hectare plots, which are common in the tropics, where an entire hectare will be inventoried for the amount of carbon.